Hello, good afternoon. Shall we wait for a few more minutes so that others may join? So, is that before that, if you have any questions from the week to graded practice assignment, you may ask, or week one also. Okay, so can you please briefly, anyone briefly define what you discussed in the last class? You can unmute now. Tell. Okay, fine. Let's recap what we are discussing in the last class. So, in the last class, we have discussed something about the number systems. In that, we have discussed something that two different types of number systems like binary representation, octal, and hexadecimal number system. And I also discussed something about the two types of numbers, which is signed and unsigned format. So if it is signed numbers, we can able to define in binary format either by this representation called signed magnitude representation or two's complement form. So we discuss some brief discussion about the two's complement format, and today we're going to compare with signed magnitude format also, and finally we will come with which one is. I mean, finally we are taking a signed representation by using two's complement representation as a final most thing. Okay. Well, shall we begin today's topic? Yeah. So let's take some number. Say for example, our today's date is 22 1 2025. Okay. So this is some. Yeah, please.
Sir, your screen is not visible.
Oh, I'm sorry. Thanks for reminding. Yeah. Now I think it's presenting. Yeah, fine. Well, these are the things I'm discussed in the last week, and we just start with the today's topic, which is nothing but I'm just taking some random example. So our today's date, 22 1 2025 is the date I had taken. So if suppose I want to store in the system, how does it stores? Means actually this is not a single numerical number. Of course, we know that date is separated, month is separated, and year is separated, and in the I hope you know that in the structure in you supposed to create the date in your computer program using programming in C. What you supposed to do, you supposed to use with the structure. Am I right? Yeah. So these each are separately handled. Well, so now in that case, I'm just taking the first number, second number. If it is again, it is equal to 1 only, and a third number, three different numbers. So I want to represent these numbers. So can you just tell me what is the maximum length of bit is required to represent this particular date in binary format? How many bits are required for representing? So your date start from number 1, 2, 3, 3 up to maximum number is 31. Right? There will be no more than that number like this. So if I want to represent in numbers, binary number system, what is the maximum number is here is 31. How do I represent number 31 in binary?
1111.
So 5 1. So number of bits is required here is maximum 5 bits are required. So for date, I need 5 bit. If it is having any, yeah, please. Dakshika Soni, unmute and ask. Can you able to unmute or not?
Sir, your voice is breaking.
Is my voice is breaking to
No,
everyone?
sir. No, sir. No, sir.
It's clear.
No, sir. It is
Yeah.
correct.
No, sir, it is correct.
Okay, ma'am. Please check your network connection now, and I'll just proceed. I mean, let me go on it. Okay, fine. So if I want to represent this particular number in binary format, I require at least 5 bits. For month, how many bits are required at least?
2 bits.
Why?
Sir, 1 bit, sir. Only
uh,
0. Okay, 2
1
bit.
bit.
Month is not only this number. Maybe I can have months from 1 to 12, right? So 12 can be represented. Maximum number is 12 in this case. So 12 can be represented by 1100. So
3 bits.
4 bits are required.
Okay.
Okay. So I need 4 bits. For this number, how 12 bits?
11 bits.
If it is 11 bits, 2040, yeah, exactly, 11 bits. So 2 power 11, which gives 2047. Sorry. So if I include from 0 range, if I for the 11 bit, it range from 0 to 2047. Okay, is it fine? I'm going to tell the range only. Okay, what you said is right. That is 2048 combination of numbers. Number of states is 2048 states. So like starting from state 0 till 2047. Total number of states is equal to 2048 states.
Sir, but this will be valid only until the year 2048. So
Yeah. After that, then again, that's what the problems begins. That's why we can go increase the state up to. I mean, when you look at your computer, also maybe there is a year list will be like this, or else some computer may be having the date here will be like this, not beyond this. Am I right? Of course, this is too large compared to the previous number 2999. Initially, before 2000, before Y2K problem, the year is defined like 1999. That's why the people world think that only after 1999 there will be no more year. But it's just a matter of how many bits you are used for. Is it okay?
yes, sir.
Well, so thing is, number of bits is maximum bit is maybe if you use extending the up to 12 bits, that depends on it. Based on that number, 4000 up to 4040 4097 GS will be able to display on it. Is it okay? Well, here in this case, I'm supposed to mention this particular application. If I'm trying to draw any kind of this kind of application to showcasing my date, I mean calendar in my system for deciding these cases, or do some manipulation with a calendar, because I'm asking today's date is 22. What will be the day, or what will be the date after 5 days? If I ask something means, or what will be the date after 10 days? If I ask that such a case means you can able to proceed properly. Am I right? Yeah. So in this case, number will be only in unsigned case. Whereas if it is a signed case, not like this example, if you go in another application, let's go take some other example. Can you suggest some example which the number comes to negative also? Some application.
Bank
Yeah.
balance, sir.
Bank balance, minimum value is 0.
Temperature.
Okay. Temperature minus 7 degree, 4 degree. Okay. Temperature is also validable. Any other example? Measuring of temperature. So this is application.
The voltages.
Voltage cannot be a negative, but we can change the polarity and we can define that it is a negative voltage. Well, in the multimeter you can see number like -12 or +12 like this. Therefore, if it is so means it's because of your where you are probing yourself. For example, positive probe is if you connected the negative and negative probe is connected to the positive, of course the result will be reversed answer, negative answer. If you measure properly, you get the positive answer. Okay, I'll consider that way also. So there is a chance of voltmeter measuring where you can get
So
positive.
sea level.
Yeah, from the sea level. Yeah, these are the examples like sea level measuring, height of depth of sea.
Speedometer.
Speedometer, negative speedometer is not at all possible. I mean, is it possible? Because one can start right or stop. If it start right at acceleration, when because of acceleration the speed increases, or it can comes to down. Minimum value is 0. So that comes to this unsigned cases. So these are the applications where you can, some other example will be there, but these are the examples where I can able to handle with the numbers of negative also, negative as well as positive. What is the usage of this number system, or what is the usage of this temperature measuring? Means maybe I can do some measure like suppose I'm getting the temperature is -5 degree, and what I am supposed to do is till what temperature I should do such that I can bring to +4 degrees Celsius. So I should calculate X. So what is the expression? This is my target. This is my measured one, and I want to find this one. This is equal to what?
9.
4 plus of input temperature, which is nothing but -5. So expression wise I'm talking. So in this case, what you are supposed to do is you take the target value, which is 0, 1, 0, 0. You take another value, which is equal to -5. And if I do suppose, if I process something, I should get the desired value, which is 9. Am I right? Okay, I'll just redraw it because of confusion. So this is the final most case. So let me have, this is input 1. Input 1 is -5. Input 2 is don't know, which you called as 9 voltage. So for example, 9 degree. My target is equal to 4. So I want this final most answer. So you determine like this. So how you're supposed to do is this -5, which I represent in binary fashion. So it is equal to what in 2's complement? 8 plus 3, -8 plus 3. And of course, this is not possible. Okay, maybe I can put one more number 1. This is equal to 0, 1, 0, 0, 1. When add these two number, what is I supposed to get is 0 carry 1. 1 plus 1 plus 0 is 0 carry 1. 1 plus 0 plus 0, 1 no carry. 0 plus 1 plus 1, 0 carry 1. 1 plus 1 plus 0, 0 and carry. However, in the last class itself I defined it. I supposed to have 5. In this case, I have 5-bit case, 5-bit register or 5-bit storing element. So it is supposed to store this number, which is 00100, which is gives +4, which is your target value. So I don't do any other operation. I simply do the same normal binary addition. What I did, the same binary addition I did with One number is as given number, another is a negative number, which is also represented in 2's complement format. So I am not taking any extra steps at all. Any manipulation, no manipulation I did. Just I did with the available negative number in which is represented in 2's complement format. I did so. Is it fine? Is there any question or do you have any doubt?
Sir, I have a doubt in
Yeah, please.
There was 0, 1, 1 in the second order, and we took 0 and 1 carry, sir. That,
0
yeah.
is a carry. Okay,
sir.
and 1 and 1 is 1. This one
Yes,
is
sir.
from -5, and this one is from +9. Okay,
So it will
of
become
fourth bit.
0 and 1 carry.
Yeah, 0 and carry 1. This one here
Okay,
it is 0.
okay, sir. Understood. Yes,
Yeah,
yes.
it is keep on prolonging it. But final answer is settled answer is I have only 5-bit content, which is this, and one more bit which is discarded because there is no place for storing this particular extra carry bit, which is
Sir,
the
but
6th bit.
okay, okay.
Okay, this is the 6th bit. Okay.
So what we are doing is just for subtracting a number from a given number, we are just saying you put in the 2's complement of the other number and you add that, and then you get the subtraction operation is converted to a addition operation using the 2's complement.
You think like that, okay, but point is not like that. I'm having one number which is just a number. I don't think whether it is a negative or positive, which is going to represent in 2's complement format as 11011. This is a 2's complement to equivalent value of -5 in binary, which is represented in 2's complement representation, which is I already told you with the expression I told you, right?
Yes.
Yeah, based on that expression you get this. I'm going to add this binary value with the another binary value, which is what you just told, like this is said to be input 1, this is said to be my input 2. I want to find what is the target value. Okay, if my input 2 is 9 and I can able to determine my target is 4. Normal mathematical calculation -5 plus 9 is +4, that we know. So here I'm supposed to get the answer as 01000. This is 00100 is the answer I want to get. So here my +9 is that 1001. Okay, so I feed this number, I feed this number which is taken from the some sensing unit. Okay, then I find the target value. Or if I want to know this value, okay, you keep this value as it is. Let me put this value as it is, and 00100. If I take that negative number to the positive number, you have to take in respective fashion, which is equal to +5. What is +5?
101.
101. So I represent in 5-bit fashion. When I add these two numbers, it will get this number 1 0 0 carry 1. 1 plus 1 0 plus 0 is 1, carry 0, 0 plus 0 plus 0 carry 0. That's it. So we get the same answer.
Okay, sir.
Okay.
So sir, basically we reverse 2 complement and then we add, right?
Reversing 2's complement and we write. Okay. But point is, what you're saying is indirectly same, but for manipulation purpose only, or calculation purpose only, you are saying like this. What is my objective here is there is no need for any manipulation at all. It's just a lookup table like this. For -1, it is all ones. N number of bits will be all ones. For -2, it will be n number of n-1 of 1 with the last 0 is element like this. So this is a 2's complement representation I'm telling. Okay, as per your statement, -1 is the 2's complement representation. If I do a normal methodology of inverting all the binary equivalent of this -1 and adding this with 1, which you call it as a 2's complement operation, then that produce the inverted value of this number, which is equal to +1. Okay, that is just for handling how to. This is for you how to handle the find the binary equivalent value. but I'm not trying to force you that to impose you that thing here. I'm just telling you you have to make up that expression as it is. Say suppose for example, let's take -7. I want to get -7. Okay, so I can be able to represent in 4-bit fraction. So -7 can be is equal to -8 plus 1. Am I right?
Yes, sir.
Okay, -8 is equal to, which is the lowest or minimum number in 4-bit format, which is 1000, which is equal to -8. Okay, is it fine?
Yes.
Yes.
That is -2 power 3 plus all the things is 0, which is equal to -8. What is +1, which is equal to 0001? Here's -2 power 3 into 0 because here it is 0. Next, adding with 0 times of 2 power 2 plus next 0 times of 2 power 1 and the last 1 times of 2 power 0, which is equal to 1. Is it fine?
So -7.
Okay, I'll just read in clear fashion. +1, I can write it as it should, same formula. Okay, it is 0001. This is at 1 into -2 power 3. Sorry, yeah, it's 1, not 1, 0, because here the bit value is 0, right? So 0 into 2 power 3, then 0 into 2 power 2, 0 into 2 power 1, and 1 into 2 power 0. This is equal, this gives 0, 0, 0, 1. It produces equal to 1. When it repeat the same operation for the above case of 100, okay, you will get the -8. 100, which is equal to 1 into -2 power 3, which gives -8. Remaining things are zeros. 0 into anything gives 0 only. That's why I'm simply mark as 0. You have to do the same kind of process. So finally, I'm getting -8. Is it okay?
Yes, sir.
Okay, now let me try to explain this number. So I want to write -7, which is equal to, I told you, -8 plus 1. -8 is 1000 plus 1 is 0001. Adding these two number. Am I right?
Yes, sir.
Okay, so -7 is this. So if you want to compute, check to cross check, let do the same process. 1 into 2 power 0, 0 into 2 power 1, 0 into 2 power 2, 1 into -2 power 3, because only for signed case only this is a process for 2's complement representation. This is 1 0 0 -8 gives -7. Can it, is it clear?
Sir,
But sir, -8 is not equal to 1000.
-8 is not equal to, I didn't say -1 is not equal to 1000. It is equal to 1000.
But sir, there will be like if we take the 2's complement of 8, like this
Okay,
value is +8.
yeah.
1000.
So I just want to emphasize one more point here. Well, let's say I'm taking 4-bit representation. In that 4-bit representation, 1 bit is I used for signed representation. Remaining 3-bit I'm going to use for data representation. Okay, so 3 bits can be 2 power how many combination?
8.
Okay, totally 8 states are there. Here I can have 8 states. Like, okay, I'll let me put in the next page.
Then, sir,
So
most
0,
digit is for negative ones.
most of the stages are,
Most significant digit is
yeah,
for the negative sign.
most significant bit is used for differentiating whether the number is positive or negative. If the particular bit is 1, it is negative number, or else is it zero, a positive number. So let's take this number 000. This 0 is equal to digit 0. 0001, it is equal to 1. Okay, Okay, so after this, the most significant position, I mean, most of the 3-bit is filled here, which is filled with logic ones. So this is my maximum value of number, 4-bit number. Maximum value of 4-bit signed number. For unsigned number, you know what is a maximum number, which is all ones. But for here, signed representation, 1 bit is used for signed bit. So remaining bit is all ones. Remaining have 3 bits. The 3 bits are all ones. That is my maximum value. Likewise, I have to suppose to follow the second case. Okay, so when I increment one more time, I'll get the answer as 1000, which is equal to minus 8, 1001, which is equal to minus 7, minus 6, so look at here. If it is all ones, it is a negative number.
Sir, why can't we just use it like the zeros will represent positive and ones will represent?
For that K, zeros is for positive, means which zeros you are talking about?
Like 1001 will be minus 1. Like 1 at the very start will represent
Okay.
negative sign.
Well,
And why?
so again, if you think like this, if your what is your point is after this, if I call this is minus 1.
You said the first is minus, the last
Yeah.
digit shows.
Yeah, if I do so, there is again one more computation I required. Here there is no much computation. The same generic method which so far I use that formula, right? In that formula itself I can supposed to do, or else I should make my complex. I have to increase my complexity. If you say like this, if you want to say this number is minus 1 and this number is minus 1, so on, then I supposed to proceed with the previous operation also, like this operation.
Okay, sir.
Okay, if it is two's complement format, which I so just now what we have discussed, in that case I'm not doing any other extra operation. I'm just straight away putting with the applied formula. This applied formula only I just executed here. So to represent minus 7, it is just 7 minus 8 plus 1. So minus 8 I know which is the lowest number, which is 10000. Adding with one more number gives 1001. Like this I can able to easily identify the number and I can proceed with it.
Okay, sir.
Well, and so here this is my minimum negative number. Okay, so in such a case, if you want to if it is a 4-bit signed number, the range is from minus 8 to plus 7. Is it fine?
Yes, sir.
So if I want to represent plus 8 in 2's complement representation, what is the value supposed to put?
In how many
Sir,
bits?
0, 1000.
I supposed to enter with 5-bit because the 4-bit cases, these are the set of numbers. For 4-bit cases, sorry. For 4-bit cases, these are the set of numbers. So maximum number I told it is plus 7. Minimum number is minus 8. Okay. If I'm asking number which is not in the specific case, I'm not able to put in your 4-bit. I can't able to accommodate in the 4-bit. So I have supposed to go with 5-bit. So what is the value of minimum number of minus 9?
Sir,
what will be the minimum number of minus 9?
Sir, it will be minus 8 plus minus 1 in 2's complement forms, and the addition, the carry of 1 will be neglected. And it will
How many
not be
bits are
minus 9,
required?
but
Sir,
it will be
100000.
some number inside this 8 to minus 8 to 7.
But I want to represent minus 10. I'm asking you how many bits are required to represent minus 10 as it is without any discarding.
But sir, then we will need more bits, right, for minus 9?
Exactly. That's why I'm asking what is the value and what is the number of bits. How many number of bits are required?
Sir, I think 5
4
bits
bits will be required.
Of
5
course,
bits.
4-bit is not required because in the 4-bit case, the minimum number is -8. But I'm asking below the minimum number of -8 to -9. So
Five
-8
bit.
is much lesser than
5
minimum.
bits, sir. Till -16 we can represent.
Yes, exactly. So in such a case, I have to suppose to execute with the 5-bit. Okay. So the range of number is -16 to +15.
Plus.
Is it okay if it is a 5-bit? Okay.
Yes.
Yes, sir.
So I'll just rewrite here. For 4-bit, the range is from -8 to +7, and 5-bit is -16 to +15. Okay, can you minus 2 power
N.
what?
This is 2 power n minus 1.
Yes, 4 is by n bit, 4 minus 1 bit till
2
2 power same 4 minus
n
1 bit.
minus 1.
Yes,
The whole minus.
I'll get the answer as +8 and
Minus
subtracted by -1. So in terms of generic format, I can write like 2 power n minus 1 bit, where n is n bit, what are the size of bit, till 2 power n minus 1
The whole minus 1.
whole minus 1. So this is a differentiation. You have to categorize. I mean, this is very important thing. And each state. So totally, how many states I may have for n bit? How many numbers I can able to tell, including positive and negative numbers? Totally, how many numbers are there?
2 raised to n.
Exactly. Simply, it is 2 raised to n numbers are there, and 2 raised to n number can be positive off cycle, and positive half of the thing will be positive number, and half of the thing will be negative number, including zeros to the. And every numbers as distinct number. They all are unique numbers. All are unique numbers or unique states. But in the signed magnitude representation, which is too easy for understand, but too complicated to design it circuit. Okay, so if I suppose to represent with maybe I can start with 3-bit, so that it will be easy for us. So as usual, 1 bit is signed bit, and the remaining 2-bit is for your data representation. Okay, so in this case, if 0 0 data with the signed data is 0, means it is +0 0 0 1, which is +1, 0 1 0, it is +2, 0 1 1, it is +3. After that, can I extend it?
No, sir.
No,
First-
Similarly, at the bottom side, 1 0 0, which is expected like, which is -0, 1 0 1. This is equal to what? 1. But
minus 1.
since because of 1 pin,
This is what I asked, sir.
this is signed magnet representation. Yeah, if you use this way, what happens? You can't able to do arithmetic operations. For any arithmetic operation, it is quite complication to get the same answer. So 0 1 0, which is this magnitude of this number is 2, and since because of signed bit is 1, I can put as -1. Then 1 1 1, which is equal to -3.
-3.
So anyhow, for 3-bit, I can have 8 states, and 0 is appeared twice as +0 and -0. Is it okay?
Yes, sir.
And hence what happens, for representation of 0, which is actually it is 0, there is no meaning of operation with +0 and -0 mathematically. But here there is separate states, so one state is totally wasted in 3-bit case. Similarly, for n-bit case or all the n-bit size, one state is not used, unused case. Hence, this is not suitable for arithmetic operations. Or if suppose again I want to do arithmetic operation, then I have to suppose to do some extra combination circuit to add on, include it. I should fit it with it, such that I can able to replicate the exact expected mathematical answer. Okay, any doubt in this regard? And simple example, let me take -2. plus 2. Minus 2 is equal to 110 and plus 2 is equal to 010. And adding these two numbers, 0, 0 carry 1, 0 carry 1. Well, we'll get the answer is equal to 0. Which 0? Whether it is positive 0 or negative 0? It says to be plus 0. Okay. If I take 0, 1, 1, which is equal to plus 3, and taking minus 1 is what? It is
101.
101. And adding these two numbers, I supposed to get plus 2. 0 carry 1, 0 carry 1, 0 carry 1. Again, this gives the answer as plus 0. Is it okay?
That's why we don't use signed.
Yeah, exactly. That's what is not suitable for using signed representation. So that's why we are focusing with the simplest and easy approach of 2's complement representation. Any doubt in this regard? Yeah. Okay. And I hope you have gone through the activity problem. Any question related to activity problem of week 2? Okay, let me do some basic example. Okay, I think I can share my full screen so that I don't want to write the question again. Sorry. Okay, so let's try to identify the base value of the first problem. So problem number 1. Am I missed anything? Yeah. Well, one more point I want to emphasize with the advantage of 2's complement, and actually that is about the how do you extend your number of bits. If suppose I have represent in 2's complement representation of particular number in 4-bit size, and now I want to implement the same number in 8-bit size. It means in simply I'm telling you that initially I was worked with 4-bit processor or 4-bit controller. Okay, now I want to switch to the 8-bit controller or 8-bit processor. So what I supposed to do, I want to rewrite the entire number. There is a need for a calculation and so on, as like expected, but it's not so. What is simply there, we can simply padding with a proper value so that it becomes, well, same answer. I think that you can study in the next week, following week. So it's initiation for you to think in that direction also. There is other advantages, which is nothing but 2's complement having signed extension is, and that extension is very easy. Make your circuit very simple. The same circuit I can reuse for extension of any number, some 4-bit to 8-bit or n-bit. That's a problem. I mean, that is not a problem. That is a benefit for us to execute it. Well, so any question, or I can move to the problem solving through activity problem number 1, which is 430 to the base 10, which is equal to 660 to the base 6.
Sir,
Yeah.
sir, I have burned out in sign extension, sir. Suppose 11-bit number and we have to move the sign bit, extend the sign bit. Then what we do? We move the 11th bit to 12th position or add the one extra same bit at
Okay,
the 12th position.
since you are asking with big number, coin may not be too complication. Let me explain the same with a simple number so that it may helpful for you. We know that -8, which is equal to 1000, which is a minimum value for which can be able to represent in 4-bit. Well, so I'm asking the same -8, and I'm asking to represent in 8-bit or else 5-bit. Maybe it may be helpful for you, right? So 5-bit, I'm then simply putting like this. This is also acceptable way. Let's check with it. So what is this number? First number is 1, second number is 1, third number is 0, 0, 0. This is equal to 1 into 2 power of -4 because I'm living in 4th position. Then 1 into 2 power of -3. Sorry, not -3, +3. Then 0 into anything, everything will become 0. So what is the answer gives? -16 plus 8, it gives -8. Is it what you asked for?
Yes, sir.
Okay.
5 multiplied
you-
with -4, sir.
Why I have -4? So first of all, why I here in this time I'm used multiplication of 1 into 2 power -3. Why I supposed to put -3 here?
Because it is a negative bit, more significant
Okay.
negative bit.
3. Why I'm putting 3 here? That's a question. This is position
Because I am
0,
in third, yes, sir, third position.
position 1,
Yeah.
position 2, position 3. This is at position 4. So I supposed to put only for minus a power
Sir,
n
will
minus
it
1.
be 2 to the power -4 or -2 to the power 4?
I'm sorry, I forgot to put minus here. Oh, you asked that one. Yeah, sorry, you are right. Sorry, I mistakenly taken. So 2 power of, -2 power of 4. That's the correct.
Yeah,
I'm
sir.
sorry. You mean this only, right? -4. I'm sorry. I thought that this minus only. I imagine in that area. See, that totally different. That takes to the different problem. That not give this exact 16 also, -16 also. Thanks for supporting me. Okay, is it okay?
Yeah, sir.
So even if you extend with any number of 1, okay, that particular it gives the same number only. It again gives the same -8 only. That's the specialty of signed number, signed magnitude format. Sorry, 2's complement format.
Okay,
Whereas
sir.
in the signed magnitude format, it's totally different. I will discuss that also now. Okay, let's start with the first problem. And 432 to the base 10, which is equal to 660 to the base x. What is the value of x? How to derive it? Okay, I'll have this formula, right? So I equal to 0 to n minus 1 some a power n in a power I into 2 power I. If you process this particular formula, after execution of this particular formula, I get some one number. Okay, whatever number, I don't want that. But what is the format of what number system I will get at last? Whether it is base 2 or any base, B will be
It
either
will
2.
be n base n.
No, either it is base 2 or base 8 or base 16 or any base, I'll return with single base only, which is equal to always decimal 10. Any number system, you take any number system. On adding of that number, we get the same thing.
Okay.
Let's take some simple example. Let me try with the octal number. Okay.
Then sir,
Numbers.
the D will be 10, right?
No, I'm telling that base value here. So let's take some base value like 1 to the base 8. So base is B is equal to 80 now. Is it okay? Now the
Yes.
base is 8. Okay. So what is equal to decimal value means normally up to 7, it is 7 only. And decimal number 8 is equal to 10. Decimal number 9 is 11. Decimal number 10 is 12. So I should supposed to get answer as 10 in base 10. Is it okay? These are the decimal numbers. These are the octal numbers. Is it fine?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So let me apply this above formula here. 2 into base is 8 a power 0. Then 1 into 8 power 1. It gives 2 plus 8, which is equal to 10. Finally, I get the answer in decimal only. You can try in any number also. Let's try another number like, for example, number 15 is F, 10 is 16, 11 is 17. This is in hexadecimal format. 112 is 18, 113 is 19. Any number. Can you choose 13? So that I get the answer as 19. So 13, 3 into its base is 16. 16 power 0, it gives 3. 1 into 16 power 1, it gives 16. Finally, it gets the answer in decimal only. Okay.
Yes, sir.
Yes, sir. Yes, sir.
So this formula says like this. So I can write this value as 6 into x square, because I don't know what is x, plus 6 into x power 1 plus 6 into x power 0. Is it okay?
Yes, sir.
Okay, and solving this particular problem, we will get x square 6x plus 6 equal to 432. Both are in decimal format. Okay, 6x square plus 6x plus 0, right? Okay, 0 equal to 432. Taking 6 common, or 6x common, we'll get as x plus 1 equal to 432. Any possible means 6 can be processed by 88. Okay,
No, sir, 72, I think.
sorry,
72, sir.
yeah, 72. Okay, else I can write what is another option? X may be equal to
Sir, can you please check it? It is like 0 or it 1? 6x square plus 6x plus 1, 0. Can you please check it?
okay, I'll write 660, right?
No. Yeah.
That is 0 into well, okay, it is comes to x square plus 1 equal to 72. So what is the x value such that it gives 72?
X is equals to 8.
Yeah, but how can we simply do it so?
Factor 8 into 9. That's
Sorry, your voice is breaking.
is 8 and 9. 8 into 9, 72.
Okay.
There
You
can
can
be
say,
more
okay.
than one values.
No, there should be only one value. I can write as x square plus x minus 72 equal to 0. You can do the x is equal to minus 1 plus or minus root of b square plus 4ac. What is the answer?
So we can factorize it. No? 9 8 are 72.
9 8s are 72, but there are two answers, right? I don't want two answers. I want only one answer.
No, sir.
Minus 9 and 8.
Okay, yeah. 9
Minus 9 and 8.
Yes, sir. What I have.
base number may not be negative number. So 9
It's
Minus
8,
9 and
8,
8. We will get
x plus 8 x minus 8 into
x minus x plus
X plus 9.
x square. Okay, it comes to okay, fine. It comes to the answer like 72. Okay, so where x is equal to 8 is a valid because it's a positive number. As you said, it is minus 9 is not a number.
Yes, sir. That's what I told you.
Yeah, sorry, I was late pick up. And fine, next problem, I hope you can handle by, is it possible by handle by yourself, or you want benefit of why you are going for hexadecimal? I think I asked you on the type itself. So I have these numbers, okay, and I'm supposed to convert hexadecimal number to decimal number or binary number, okay, binary to hexadecimal number by splitting it with 4 bit. Okay, so in the binary case, okay, any numbers, let's say this is at position 0, 2 power 0, this is at position 1, this particular position, and 2, this is at position 3. Okay, so it is equal to h 4 2 1. So if I have 1 1 0 1 means it is equal to that of 8 4 2 1 combination. Can you get it?
Yes, sir.
Well, and adding up this number, okay, we get the answer as what? 13. Okay, well,
Yes.
so here we have some numbers which is 1 1 0 1 1 0 0 0 0. 4 zeros are there, so we have to separate by 4 bit. This 4 bit constitute answer 0, this 4 bit constitute by b value, and this constitute to 1, because I leading value as 0 0 0. I can put it up such that it is equal to, okay, in 1. Yeah.
Okay. Okay, sir. Yes, sir.
Yeah, I think same cases for the next problem. And to convert this given octal number to decimal number, the same formula, which is 125 5 into 8 power 0, 2 into 8 power 1, 1 into 8 power 2, and resultant value, if you add it up, you get the answer as decimal value. If it I'm giving the number like 0.125, again I want to convert to decimal number, means okay, that is 0 into 8 power 0,
Uh,
1 into 8 power minus 1, because I am just following after the decimal point. So 2 into 8 power minus 2 and 5 into 8 power minus 3, and add it up, you get the decimal number. Is it fine?
yes,
Any
sir.
doubt in this? Do you have any question regarding this?
No, sir.
Yeah.
No, sir.
Well, if the given number is hexadecimal number, 125 to the base 16, same cases, 5 into 16 power 0, 2 into 16 power 1, 1 into 16 power 2. You get the answer as 5 plus 32 plus 256. So add it up, you get some number. Okay, the same cases, 0.125, 0 into 16 power 0 gives 0, 1 into 16 power minus 1, and 2 into 16 power minus 2, 5 into 16 power minus 5, minus 3. So give the, you just add it up the answer, you get the by decimal value. So decimal conversion is just simple straightforward format. Any doubt in this regard?
No, sir.
Yeah. Mm. Okay, 2's complement format of number 5 in 4-bit is what? Since it is a 4-bit number and this is a positive number, substitute with the 0, remaining is as usual. And one point I want to emphasize it, I think I can go in the previous pages. Yeah. So I think I can copy this particular part. Okay. So look at here, I have the value of 0 here as 0. In normal unsigned number, 0 is 0. This is unsigned to the 1, unsigned 2, unsigned number 3, unsigned number 4, unsigned number 5, unsigned number 6, unsigned number 7, unsigned number 8, and so on. It's keep on going, I hope you know. And when you compare this unsigned number of positive of number and the positive of number here, both are equal. Is it okay?
Yes, sir.
That's a good thing in 2's complement format representation. So there is no need to worry too much of complicated thinking. What is a plus value of 5 like this? You can straight away, you can write it up. Okay, and the same problem I asked, how to represent the same 2's number 5 in 8-bit format. Okay, you're supposed to append with 0101 is a positive number, which is 4-bit size. Just append extra 40 to form as 8-bit. Since the most trailing bit in the 4-bit size is 0, I can extend, even while extending, I just supposed to append with zeros only. I should pad with zeros only. Okay.
Yes, sir. Okay.
If it is a negative number, the most significant bit of the negative number is 1. I should padding with ones. Okay. So when you computing again, 0 into minus 2 power of 7, 0 into 2 power 6, all the so on, and 1 into 2 power 2 plus 0 into 2 power 1 and 1 into 2 power 0. Finally settle to 0, 0, so on, and finally it comes to 4, 0, 1. It comes to answer 5. Okay. Yeah. So let's take another number. What is the negative number of minus? What is the value of minus 5 into 2's complement representation, which is represented in 4-bit size?
1011. I think.
1011. Exactly, because this is 8 minus 8 plus this. If I add these two numbers, use 3. Minus 8 plus 3 is use minus 5. Is it okay? 1111 minus 8 plus
7.
because all are ones, I can add it as 7, which is equal to minus 1. I hope we can be able to solve. Am I right?
Yes, sir.
Yeah. So if I extend this number minus 5, or else let me take some number randomly and let me check it up. 1011111111. Yeah. So can you tell me what is this number is? What number it is?
Signed or unsigned?
This is 8-bit number. 8-bit 2's complement representation number. So guess what is it? Is it signed or unsigned? If I say 2's
There is
complement.
minus 2 to the power 6.
This is 8-bit size, so it is minus 127 plus this number is 1 0 1 2 3 4 5 6. 2 power 6 is 64, right? So plus 63, it gives 7 64, which is minus 64.
Yeah, and minus 2 to the power 6 is minus 64.
Why minus 2 power 6?
Because I took the 2's complement. That's why.
Okay, that's why I'm emphasizing you. Please don't do operation of one's complement adding ones like this 1 0 0 0 0 0 0 0 something, then adding 1.
No,
this,
not adding 1, just
yeah,
because
don't.
we are doing in the reverse direction, so we don't like we need the positive value only, and then we can add the negative sign ourselves.
Okay, nice. Okay, super. Fine. So this is a way of writing. Well, finally, this problem minus 5 in 8-bit. Four-bit is 1011. 8-bit will be 1011 extended by 1111. That's it. Okay.
Yes.
And okay, then number of ones, these are the second thing. Well, now next number cases, I'm just taking the same plus 5, represent the same plus 5 in signed magnet format. This is signed magnet format. Am I right?
Yes.
Yes.
In 8-bit,
The preceding with the 040.
so the most significant bit is 0 because of signed representation. Remaining number is 0101, and remaining you are supposed to put zeros. That's it. So what is minus 5 into signed magnet representation?
These
It will be 1 and then 3 zeros.
No, 1101, which is for 4-bit size, and in 8-bit representation
1111101.
3 zeros and then 0101.
0101, exactly. Okay. So the total magnitude of this number is plus 5, and because of this 1, we can tell it is a negative number. That's the difference of it. I hope we have covered up all the activity problems. And any other question regarding this week content?
No, sir.
Okay.
I am confused with the -5. Earlier we
In two's complement or in signed magnitude format?
in sign magnitude format.
Okay, so -5. Okay, so we can suppose to put fill with 1 bit, which I'm just talking with. I'm just talking about 4-bit cases. Remaining 3-bit is the magnitude of 5. What is the magnitude of this plus -5 is?
Negative.
Magnitude of plus any magnitude is nothing but absolute value. What is absolute value of plus 5?
5 5.
5 can be represented as 101. Am I right?
Yes, sir.
And this is negative number, so I supposed to fill this position with 1. Same number I'm asking in 8-bit. Okay, the magnitude is 101, and the remaining that is 3 bits. After that, 4, 5, 6, 7, 8. 8th bit is also 1 to represent this negative number. There is no other numbers. I just define this total number is equal to the magnitude of -5, which is 5. So the way is 0 0 0.
Okay, sir. Thank you.
Okay, welcome. And so in the next week content, what are the things we're going to discuss in next week is all about Boolean gates, and is Sonali.
So I have a doubt. You have written -2 to the power 3 in that slide.
Okay. Which problem? This problem?
Yes, sir.
Okay, what's the doubt here?
So how do you written that -2 to the power 3?
Okay. Okay. So this is actually the signed magnetic two's complement representation. So two's complement representation, we already discussed that there is a basic formula. Okay, let me write that values, binary value like this. For 4-bit of 8-bit, let me consider 8-bit. So A7, A6, A5, A4, A3, A2, A1, and A0. This is your 8-bit binary number. So maybe I can have with 10111010 like this. Some number is I have. Okay, so how can I represent this in decimal? So whatever I'm doing some summation operation with the weight value of ith element and 2 power of ith element, I'm doing so and so, I'll get a decimal equivalent. This is easy for unsigned case, but for signed case, what is we have represented in the same kind of formula is 2's complement formula, which is equal to I equal to 0 to, here it is 8-bit, right? So 8 minus 2, up to 8 minus 2 I is supposed to execute. Okay, added with one more number, A7 2 power 7, it should be in negative, or minus 2 power 7. If you add this case, I'll get the equivalent number which is in decimal format. Let's try to do with a 4-bit case. Okay, I told you that 1111, which is equal to -1. Is it okay? Can I choose this number? Or any other number you would like to give means also you can give. Is it okay? Well, so here 4-bit case, so I can suppose to write my above formula I equal to 0 to up to how many bits? Position 0, position 1, position 2, position 3. Up to position 2 I have to execute. Okay, AI 2 power I minus or plus times of A3 minus 2 power 3.
Sir?
Yeah, please.
So 1111 is equals to 15, which is equals to F, right? How do you written -1?
It is equal to 15 for unsigned number. Okay, I'm just talking about signed number, signed 4-bit number, which is represented in 2's complement format. It's a 2's complement representation. That's what I'm discussing right now.
But it should be, sir, 1 and 000 for the -1 also.
1 and 000 is equal to -8. Okay, 1 and 000 comes to be -8. That's why I'm trying to prove here. Okay, shall you do?
Yes, sir. Yes, sir.
Okay, this is A3. What is A3 is? A3 is 1 into 2 power -3 plus, I can expand this above expression. Okay, 2 power 0 into A0 plus 2 power 1 into A1 plus 2 power 2 into A2. Is it okay?
Yes, sir.
Okay, this is equal to, what is A0? A0 is 1. So 2 power 0 is 1. 1 into 1, it is 1. Plus 2 power 2 is 2. 2 into A1. What is A1? A1 is also 1. Plus 2 power 2 is 4 into A2. A2 is also 1 here. This is A2. Sorry, not this one. This is A2. Am I right? So
Yes, sir.
this is equal to minus of 2 power 3. 2 power 3 is 8 minus 8. Plus 2 power, this is equal to 1 plus 2 plus 4. Adding it up, we'll get -1.
-1.
Okay.
-1.
Similarly, you can take the same number what you said. It is 000, right? So this is equal to at A3. Okay. Here A3 is 1 into -2 power 3 plus 2 power 0 into 0, because A0 is 0, A1 is also 0, A2 also 0. So adding 2 power 1 into 0 plus 2 power 2 into 0, final answer is equal to -8. That's a specialty in 2's complement representation. Any doubt in this regard?
No, sir.
Yeah.
Yes, sir.
Yeah. Please be strong in this number system, because in the forthcoming courses I'm going to define simply like any two numbers which are represented in 2's complement representation. It means that I assume that you know how to write that any given number in 2's complement format representation. Okay, based on that only we are going to strongly going to design some combination circuit or even in a sequential circuit also. Okay.
Yes,
So, is this
Yeah.
the first class for the week 2?
No, ma'am. Already we are last Monday we have done. Okay, I think you can go and
Okay,
look at that YouTube channel if you
sure,
want to
sir.
back. Yeah, sure.
Sir,
Okay.
one request. The sessions are not reflecting on the channel since these are unlisted sessions. If we don't have the link, we
Okay.
will not be able to see them on the channel.
I'll just add on
yes,
playlist
sir. Yes,
immediately.
sir.
If actually these are immediately creating YouTube stream, that's why it is not in the playlist. Thanks for reminding me. Now itself I update that one immediately. Or else we have the discuss forum, right? I mean in the G chat.
GChat, yes, sir.
Yeah.
BDS, we have
Yes.
open
Okay.
G space. We have the
G space. We have G space, right? You can in that. If you have any queries, you can please put it, or else please try to put in discuss one. That's quite good enough for us to view. Mostly, I can view there itself.
But sir, please try to list those
Update.
YouTube
Yeah,
videos.
sure. I will just update immediately. Don't worry. I will just do it now itself.
Thank you, sir.
Welcome.
Thank you, sir.
Yeah. Please be free and asking any questions regarding the technically. I can try to answer you. Okay, and very important thing is fundamental things, so please remember the number system very clearly. If you get any doubt, please ask any number of times. I can try to answer you. Okay.
Sure, sir. Sure.
Okay, see you all. The next after third week onwards, we're going to facing towards the direction of designing combination circuit. After fifth week and seventh week and eighth week onwards, you start marching towards the sequential circuit. Finally, if you are very good enough, you can able to bring your traffic light system on yourself. You can build yourself. Okay, I mean at least in the simulation wise.
Okay.
Let's try to do that setting. Okay.
Okay, sir.
Okay. Thank you all.
Okay, thank you, sir.
Thank you very
Thank you,
much
sir.
for patient
Thank you, sir.
Yeah. Thank you.
Thank you, sir.
Thank you.